Please subscribe to the channel and hit the bell icon for notifications.
So in this topic, we will talk about the Android sensors. Uh, what kind of sensors we have in an Android device. Actually, there is no common rule. Different type of Android device manufacturers, will make make available different kind of sensors in our Android phones. But I mean, there's actually no limitation. You can have a lot of tiny Android sensors on your Android mobile phone, whether it's from any company, and but it's these kind of sensors, they actually provide more functionalities, more kind of features, and more kind of flexibility to the user, who is using these Android devices. So what kind of Android sensor we can have? Here is I have provided a simple list of the types of the Android sensors that we can have on our Android devices. As I said, there is no limitation, but the more tiny kind of tiny sensors we can have on these Android devices, the better it is for the user, of course. So we can have, for example, ambient temperature, gravity, light, accelerometer, linear acceleration, rotation vector sensors, relative humidity sensor. We can have, for example, a barometer for the pressure measurement, orientation. For example, what is the orientation of the Android device at the moment, temperature, proximity, relative humidity in the atmosphere. So these are the kind of sensors that we can have in any Android device. Now some of these these sensors on the Android device are hardware, and some are software, or some are both hardware plus software. So I can now tell you what are the hardware ones and what are the hardware plus software ones among them. For example, the gravity sensor, this can be a hardware sensor, or it can be also a software based sensor. Ambient temperature is a hardware based sensor. Light is also a hardware based sensor. Accelerometer is also a hardware sensor. It's just hardware, on the tiny hardware on the device, on the Android device. Linear acceleration is either hardware or it is a software sensor. For example, something is coded, and based on some other parameters, you can find out the linear acceleration through a small code, Android code. And apart from that, rotation vector is also a hardware sensor. Relative humidity is also a tiny hardware device on the Android phone. Pressure sensor, this barometer is also for the measurement of the pressure, also a hardware sensor. Orientation is either hardware or it is a software sensor. Temperature is also a hardware sensor. Proximity temperature, any thermometer or something. Proximity is also a hardware sensor. Relative humidity is also a hardware sensor. So what these sensors measure, for example, this ambient temperature sensor measures the ambient, for example, the room temperature of of the place where the device is located. Gravity is, for example, uh, it measures the force of gravity. This gravity sensor measures the force of gravity, for example, that is applied on the device in all the x, y, and z axis. Z axis. Uh, the light sensor measures the light level, of course. Now, yeah, there's another temperature sensor here. We can describe this. This temperature sensor is actually the temperature of the device. This is the temperature of the device. device, and this is the temperature of the room. This is the room temperature, ambient room temperature. So that is the difference. This is the room temperature, and the other one is the device temperature. This temperature sensor is the device temperature. um, and So the accelerometer measures the acceleration in meter per second square. That is uh, for all the three x, y, and z axis of the device. And then comes the linear acceleration. This is also the acceleration in meter per second on all the three axes, x, y, z. So what is the difference between accelerometer and linear acceleration? This is includes gravity, gravity, and this excludes gravity. This is minus gravity. This is without gravity. This linear acceleration is without the gravity. So that's the difference. And the rotation vector measures the orientation of the device, by providing the rotation vectors of all the axes, for the device. And then comes the relative humidity. So the relative humidity is the measure of the dew level and the humidity level in the atmosphere, that is measured by the device. Then we have a barometer for the pressure measurement inside the device. So the orientation is actually the degree of rotation with respect to all the three axes, x, y, and z. This is the orientation. This temperature we have already discussed. This is the temperature of the device, and ambient is temperature of the room. Now proximity, as the name shows that it measures the proximity or the nearness of a certain object to the phone. It's actually used to measure if the earphone is connected or not. To the ear. And then the relative humidity, again we wrote the relative humidity twice. We have already discussed it here. So this is a bit of description of the tiny sensors that we have on our Android phones. So as said, that some companies will provide some of them, some will provide all of them, and some will provide some extra sensors. So there is no limitation, there is no set rule that what kind of sensors you will have on your device, on your Android device. So that's why now we come to our next slide. So as we talked about that, there can be different kind of sensors on different devices. There are no set rules. So that's why whenever we try to program something, for our any IoT system, for example, using an Android phone, because as we said that Android phone is actually like a gateway. It's like a gateway which has storage, processing power, and it has communication devices to transmit data to the cloud or to the server, and it has then built-in sensors in it. So it's like this gateway plus sensor devices, the same thing on one device, one complete device, that is a phone. So this so the first thing that we need to do while programming, or while doing certain implementations of any of these sensors that can be there on the mobile phone, is that first of all we find out if that particular sensor, whether temperature, pressure, gravity, acceleration, or linear acceleration, or orientation, or whatever, is actually available on the device or not. So first of all, that's why we will check the availability of the particular kind of a sensor on the device. And then the next thing is then what we will do, if we see that if a certain sensor is available, then we will add something to our code, or or software to kind of monitor those sensors, and what can we monitor those in the sensor. We can, for example, monitor the accuracy changes in the value of those sensors, or we can monitor the changes in the value of these sensors. If, for example, the sensor parameters change, and then we can also monitor them. Uh, uh, so in order to perform all these functions, like checking the availability of the sensor or monitoring the sensors, we have in Android Studio, or in the Android yeah, even in the Android framework, I would say, because you can also program Android in Eclipse and everything, and other tools as well. So in the Android framework, in our Android tool for programming, we are using Android Studio. So we have a sensor framework. There is a sensor framework, or a library for the sensors, that has different kind of classes or interfaces that we can use to kind of check if a certain sensor is available, and get its states or accuracy, or what's the and monitors the changes in the value of the sensor, and that's these kind of things. So first we have these kind of classes, like sensor class, sensor manager class. We have sensor event class and sensor event listener class in this framework or library. And what these different classes are doing, we can describe a bit here. For example, this sensor class, our first sensor class, can be used to kind of find out, or the particular capabilities, or what kind of features we have, kind of reach those features, or provide those features, kind of so that we can use them further. So we can this class provides them. This class is kind of it's like an instance of a sensor. It's like it's like the software representation of our sensor in the device, and then this sensor has certain features, that will be provided by this class, that is the sensor class. uh, so as we said, so sensor is just is the instance of the sensor itself. The sensor class. So sensor manager is like, you can say it's a service. It's like a service for it provides us a service for the sensor. Like, what do you mean by service? It means, like, for example, it provides us the capabilities to listen to the sensors, to set, for example, the rates, or the time delays at which we will listen to these sensors, or get its value changes, and uh, this sensor manager is also used to register the sensor events, register or unregister them, so that we can kind of monitor these sensors. So then we have a sensor event class. What are the uses of sensor event class? So when we use the sensor event class object, uh, we actually have access through this class to the actual values that the sensor is measuring from its surroundings, and also that at the time, or the timestamp at which these values were measured. Uh, Plus is also tells us which of the sensors, because there can be more or than one sensors. There can be a lot of sensors in a device. So which of the sensors has given these values? So this is all given by the sensor event class. And then we have sensor event listener class. So we have two kind of sensor events. Like, one is the accuracy changes in the event, and for example, if there's an accuracy change in the value of the sensor, and one is the change in the value of the sensor. So we are listening to these two events using this sensor event listener class. And then comes the next topic. uh, So after describing this framework a little bit, I think this is how we kind of program, or we kind of manipulate these sensors in the software. you know so now we can talk about this last topic in our slide, which is virtual sensor controls in the Android emulator. So yeah, whenever we are coding something related to the sensors in our Android Studio, we don't need to every time check code and check in the real Android device. We have this Android Studio provides us in this emulator, Android emulator. Android emulator, we have talked a lot, the one we are running, this software or the simulated version of the Android device. Like, let me show you. Oh, wait a second. Yeah, so this is an Android emulator. So this Android emulator has a virtual sensor controls, so that we can change the values and see what are the impacts on our app on these values. Is the change of the values is visible on the app that we created? If the accuracy changes are visible on the app that we created, and then this is, of course, is a list of sensors, or we can see which of the sensors we are changing. Of course, we can go to that particular sensor and change the values of that sensor. You have to click here, and this window will be open. Let us bring this over here at this place. So now we go to the virtual sensors, click here, and you see we have accelerometer here. We can, for example, change the orientation here, and you see this accelerometer values are changing in the X, this rotation, and now move. If we move it in the X and Y axis, you see now it will move up and down. What happens to the accelerometer values? They are changing here. Now device rotation, if you click here, this is the device rotation, and these accelerometer and magnetometer values are changing. You see that? Now if we click on the additional sensors, we can make it as it was before and click here. Okay, so go to the additional sensors. Here you see ambient temperature. So you change the values like this. These values are changing: minus 80, 32, 12, 63, 76. In the same way, we can change the value of the proximity sensor, and of course we can, when we will build the app, we will see these changes on the app. If for example this app will react to this value change events, and the accuracy change events. And in the same way, you see this is the barometer control, the pressure sensor. Just move it from here and there, 505.2, and then 889.0. This is our magnetic field sensor. You can change the value from here, go up and down. This is our light sensor. You see this is the range 0 to 40,000, and you see this is the maximum range. So you can change the value between this range. This range is proximity is 0 to 10, temperature is minus 273 to 100, pressure is 0 to 100. Right, this is relative humidity. This has also from 0 to 100. It's a percentage value. Normally we measure in percentage value. It's between 0 and 100. You see 66.3%, 79.7%, 80.2%. So these are our virtual sensor controls. So we can now again move this out. This was here, and let's move it a bit here, and I can first of all close it. So you see, if you click here at this point, this window will open. Just close again. You click here and this window will open, and then you have to go to virtual sensors, and then you have to accelerometer, you have the accelerometer and you have additional sensors, and then just modify them and play around with them and make the app and test them using by changing these values. And that's it.
That was awesome, thank you.
Please subscribe to the channel and hit the bell icon for notifications.